Hello everyone, and it's day 35 of this Unity game development journal. So, if you've been following along with the journal so far, you may have watched yesterday's video where I worked all through the night. I was just really excited about some of the stuff I was doing. I just kept on working. It ended up being like 3:30 in the morning by the time I got a video made. So, it was I was pretty exhausted. I have a little more energy today. It's like 12:42 a.m. I'm recording this video, so more energy today than the 3 o'clock recording yesterday, but anyways, let's get right into it. So today, what did I do? I worked on completing the entire map into transitions. So I created a scene for every chunk of the map. Um, I also rebuilt my entire movement script. The movement script I've been using since day one sort of is one of those free ones. I got it off a couple really cool tutorials. Um, one of which was this Zelda 3 remake by Let's Code Games. I love that guy's tutorials, so that's where that came from. But it's not the way I wanted to do it in my game. I want to not use the physics engine hardly at all. I'm trying not to use it at all in this game. I want to go really back to the early era games, like the 80s games, 90s games. Really didn't have all the tools we have right now, and they still built pretty cool games. So I want to try and build more tile-based, non-physics engine type games for this top-down. Anyways, besides the point. So I rebuilt this movement script, which allowed me to do the transitions a little differently, and I really love the way that the transitions have turned out too. So let's just dive right in and show this. So I'll split view this. The aspect ratio is on the actual game part is square. Wait, so I have to go into here. Wait. For some reason this didn't save, so I'll just, here we go. I think I know why. I think I have to save layout. Okay, so I will go into new game. So I have this square aspect ratio. That height gets changed as we move bigger, right? Um, but yeah, so that's the way that is. But we'll just take a look at the scene view as well. Just going to go down here. We'll zoom out a little bit more. Okay, so let's just walk around. So you can see the movement. I redid it all, but it still looks exactly the same. This is using no physics at all. It's just moving positions based on input. And then I have the transition, which has him walking. It sets it off, and then he walks over to the new spot, and he doesn't get shoved way too far over. It's just sort of, there you go. And I just love it. I think it's really clean looking. It works perfectly. I haven't had any issues with it. That was a little funky, but there we go. Let me just see this one more time. I'm wondering what's happening there. Okay, that looks fine. Oh no, that's normal. I just think it looks funny going up, but it's fine. But anyways, I had this whole map done. There's no colliders on it, which is what I'll talk about next. But the whole map is in here. Now, one thing I did run into is the map size that I developed did not equal out to the chunk size that I chose. So I'm choosing 32 by 32 pixel chunk sizes, or not pixels, but tile sizes. Which means there's a remainder. The tile map had to be 160 tiles by 160, and mine was 150. So there's 10 extra tiles on the top, and I put 10 extra tiles on the right-hand side there, which I can develop the map out a little bit more. So I went ahead and I've been working on putting all this red on the map here. So this is the starting point of all the colliders on the map, so all the things that you can't run through. So I did that for everything on the map. So that's pretty much done. I still have to test it, but that is finished. And I started working on the actual code for that. So well, let's talk about that right now. So the first thing I did was in this tile map model, I decided on, let's see here, where am I doing this? Right here. So I first created this get collision tile chords at map tile chord. So what I'm doing with the collisions is based on the old school games from the 90s. They often built their tile or their collision layer completely separate from their tile visual layer, and they actually did them on different grid sizes. So on 16-bit tile maps, they would do like 8-bit collision maps. so they could have more finer grain collision than they did with the images. So I want to try doing that as well. So this is not using any physics, just tiles and just data layers. So the collision is just strictly a data layer that just keeps track of where all the things that can be collided with. So it's just just numbers being stored in memory, very, very low, lightweight. And I just need a way of accessing different coordinates, right, to figure out if it is a collision or not. So that's typically the trick to it. A lot of math, a lot of algorithms, a lot of different things. So I built a couple functions to start. This one is the collision tiles chord at map tile chord. So it just grabs all of the collision tiles that are inside one map tile. So one map tile is bigger than the collision tile. So you break up the map tile into different sizes. So right now I'm breaking it up into fours. So there's four collision tiles inside one map tile, but you can break it up into anything. You can put like 8 or 9 collision tiles in one tile, 12, anything that's a square route that can be squared. So like 4, 9, 12, all that kind of stuff. So next thing I am going to, or what I'm doing here is just saying, now that I have that broken up inside, I know what my map tile coordinate is because my player's on it. It's very easy to figure out. It's tied directly to the Unity units. So one unit is one tile. Really, really easy to figure out what tile you're on. So to figure out all the tiles that are inside, all the collisions that are inside that tile, all I do is call this function. And it determines based on these equations that I came up with the 4 tiles based on their coordinates that are inside of this one map tile, and then it gives it back to you in this array, this vector2 array. So it's a cool little function just to get that information. Then I decided to build this one, which was a much bigger one. It's getting the collision tiles based on a direction. So if you're moving in a direction, we want to know what collision tiles are in front, beside, behind you, or on an angle to you. So there's 8 directions there that we want to look at. And I'm not talking about the collision tiles that you're standing on like this one does. This is the future tiles, so the ones that in the direction you're moving, what's directly in front of you. So I only grab the tiles that you could possibly touch. So typically there's only 2. If you're going on an angle, there's 4 tiles that you could possibly touch. This is a big function because it takes into account the 8 different possibilities, whether you're going just up, just down, just left, just right, or if you're going up and right, up and left, down and right, down and left. So that's 8 different possibilities that I run through and I calculate. So really the algorithm only does this bit of code right there, but it has 8 different versions of that algorithm to give you the correct collision tiles for the direction you're moving. So that was a cool thing that's done. The last one that I built is right here, which is one of my favorite algorithms I've built all year, probably in the last couple of years. It took a long time to figure this one out because it was the hardest one to build, but it's actually the cleanest, shortest, most concise one, and the most powerful. Because what it does is it takes any vector3 position on the map, so in the Unity engine, any position of an object, and based on that position, I will determine the exact collision tile that position is on, which is harder than it sounds because the collision layer and the tile unity layer are decoupled. I'm not having them be the same in any way. Like I could have a collision layer that has 4 tiles for every one unity tile, or I could have 16 collision tiles for every unity tile, right? So that number has nothing to do with each other. I can change that setting if I wanted to at any time. So this needs to work with whatever number of collision tiles is in one unity tile. So the way I'm doing that is I did pencil and paper. I drew all the different graphs and all the different charts, and I worked out equations to get this to work. And then I had to figure out, there's some numbers here that are sort of off, and how do they actually connect? Took me a little bit of time, but I figured it out. And then I generated this algorithm here. I wrote some pseudocode, and then I wrote this algorithm. And essentially, it's 4 lines. So this, and then returning. So it's really 3 lines. I can make it 1 line if I wanted to. So it's not It's not insanely complicated to write in code, but to figure it out, I was pretty excited with. And I'm not the first person to figure this out. This is probably the most basic thing in the world. But I didn't look at any references. I did it all on my own, like from scratch, just from an idea in my head, how it would work. I laid it out. I think that's the fun of coding right there. I could very easily go and search on Google for about 10 minutes and find something that somebody has done and sort of bring it in. But part of this whole thing is having fun and seeing what I can actually do myself. So this was really neat that I came up with this solution. So the first thing you have to do is figure out how many collision tiles are inside of one Unity tile. So I have this collision tile ratio that I'd get from the parser that's set in a variable here. So I already have that number, but it's very easy to determine. It's just how many tiles are on this collision map compared to how many tiles are on the tile map. And you just divide the two and you get your ratio. Very easy number to get. Um, to get my divider for my equations, I take 1 and divide it by that ratio. So if there's 2 tiles for every 1 along the x-axis, then this would be 2. So you go 1 divided by 2 is 0.5. In this example down here, if there's 4 collision tiles for every 1 map tile, that would be 4 here. So 1 divided by 4 is 0.25. So that's how you get your divider number. Now I'm going to skip this pre-zero chord here for a second and come down here. This is the equation for figuring out the coordinate, the x coordinate and then the y coordinate based on some sort of a position. So really easily, the first thing you do when you're trying to figure this out is you take your position of the player or the object or whatever on the x and you divide that by the divider. So if there's 4 in here, you just take your position and divide it by 0.25. Or if there's only 2, you take your position divided by 0.5, right? Then you get a number. Now, that number is going to be a float number, so it's going to be like 2.356 or something like that. So you got to find out how to get 2.356 to match over to an actual integer for your coordinate. So what I do first, and I did this a bunch of times in different scenarios and found a pattern. That's typically how I find these formulas. I work it out like long way by hand, and then I look at the way I figured it out and the solution, and I find patterns. So the pattern that I came up with is you floor this number, the position divided by the divider, you get like 2.633 or something like that. So if you floor that, you're left with 2. And then I looked at, well, I know where I want to end up being. I want to end up being on 3. But when I floored it, I got to 2. So that means there's a gap there. There's a space. There's a space of 1, right? So I have to add something to the floored number to get to this 3. So I added 1 to it, which is great, and it worked. And then I moved and tried to do another thing. So I divided the collision ones into another number set, like maybe 3 tiles per 1 map tile. Figured it out and found out what the gap was there as well. So I floored it, and then I had to add 1 number. Then I came to 4, and adding 1 number didn't get me there, so it stopped working. And then 5, it stopped working, and 6, it stopped working. And between 4, 5, and 6, there were all different numbers I had to add in as well. So that formula wasn't working. What I did was I then stopped and I said, well, what is the number that I'm adding in to get to the final actual answer? And is there an equation to figure out that number? You take, sorry, I just realized I hadn't tested this, but you take the collision tile ratio and you divide that by 2. So like I was saying, if you add 1 in there and your collision ratio is 2, then that's 2 divided by 2 is 1. So what I did was I said, okay, so you take that number divided by 2 and then you floor it, so you just drop it down to the lowest version of that number. And that was it. So then I thought, well, that works, and it worked for everything. But it's really weird to have this magic number here of 2. It's like, why am I dividing by 2? Like, where does that come from? So I thought about that for a while, and then I decided that what it is actually the collision tiles that come before the map coordinate of 0. So the tile map has a coordinate of 0 where it starts, right? But if you break that up into smaller chunks, then you end up with these tiles down here that come before 0. So when you do all your math, you're doing it based on 0 and then 1, and you're doing all your division and stuff. and then you get an answer that's sort of shy of the real answer. And it's shy of the real answer because you didn't take into account these numbers here that come before the 0. So all I do after I'm done this is I add those in. And you know how many there are here because you take the total number you have and you divide it by 2, and then you floor it, because sometimes this 0 ends up halfway on a number, like if there's 5 in here or something, or 3. So that's how you do that. And then you end up with your tile position, so it just works. So this is a really cool little thing that's going to be really useful. So all I have to do is just take any position on my map and say, feed it into this function, and it's going to tell me the coordinate of the collision, and then I can check if it is a collision or not. Really, really easy. This is one of the most useful functions that is going to be used in this situation, in this collision, the tile map collision. So anyways, that's that. So a bunch of code, not really tested yet, but it's ready to get going for putting and implementing the collision on the map. So you'll be able to see that tomorrow, hopefully. And thanks for watching. So subscribe if you want to follow along, and if you have any questions or comments, drop them below, and we'll talk to you later. Bye-bye.